Hello student, welcome to my channel Study with Samir. In this video lecture series, we have been learning laser. We already discussed about introduction and classification of nuclear and various types of emission like spontaneous emission, stimulated emission, and we introduced the Einstein Coefficient, which are the proportionality constant. The probability that an absorption transition B12 is equal to B12 rho, where B12 is the constant of proportionality known as the Einstein coefficient for induced absorption. It is constant characteristic of the atom and represent the property of energy state E1 and E2. Second one, the probability that a spontaneous transition is P21 spontaneous is equal to A21, where A21 is a constant known as the Einstein coefficient for spontaneous emission. A21 is a constant characteristic of the atom and is known as the radiative rate measured in unit of second inverse. 1 upon A21 is the lifetime of the upper state against spontaneous decay to the lower state. એટલે કે 1 upon A12 જેટલા ટાઈમ સુધી એટમ upper state ની અંદર રહેશે. Next one is the probability that a stimulated transition is P21 stimulated is equal to B21 into rho, where B21 is the constant of proportionality known as the Einstein coefficient for stimulated emission. It is constant characteristic of the atom, represent the property of energy state E1 and E2. From quantum mechanical consideration that spontaneous transition is not possible from level E1 to level E2. Therefore, the probability of spontaneous transition from E1 to E2 is 0. So, A12 is equal to 0. In quantum mechanics, lower level થી upper level માં એટલે કે E1 to E2 માં spontaneous transition શક્ય નથી. So, A12 is equal to 0. We may note the following points are regarding the Einstein coefficient. First one, the coefficient indicated by B are related to the induced transition. Transition induced by external photon. Thus, B12 represents the transition induced by photon from lower energy level E1 to the higher energy level E2, whereas B21 depends the transition induced by photon from higher energy level E2 to the lower energy level E1. It turned out that B12 and B21 are equal under the special condition that the quantum state E1 and E2 are single every level. ક્યારે શક્ય થશે? તો E1 અને E2 energy level same હોય તો. Third one is the coefficient indicated by A is related to the spontaneous transition. Transition occurred on its own without any external agent. એટલે કે કોઈ પણ બાહ્ય એનર્જીની મદદ વગર શું થઈ જશે? એમિશન થશે. Since a spontaneous transition cannot take place from lower state E1 to the higher state E2, we do not have the coefficient A12. In other words, A12 is equal to 0. Now we discuss about under thermal equilibrium, the mean population N1 and N2 in the lower and upper energy level respectively must remain constant. This condition requires that the number of transitions from E2 to E1 must be equal to the number of transitions from E1 to E2. Thus, the thermal equilibrium means number of atoms in lower and upper energy level must remain constant. The number of atoms absorbing photons per second per unit volume is equal to the number of atoms emitting photons per unit volume. Let's we explain in mathematically. The number of atoms absorbing photon per second per unit volume is equal to B12 rho into N1, and the number of atoms emitting photons per second per unit volume is equal to A21 N2 plus B21 rho into N2. The number of transition from E1 to E2 must equal to the number of transition from E2 to E1. We have B12 rho into N1 is equal to A21 N2 plus B21 rho into N2. હવે રો વાળા પદને એક સાઈડ લઈ જતા આપણે મળશે રો બ્રેકેટમાં B12 N1 minus B21 into N2 is equal to A21 into N2. Now further classification, rho is equal to A21 into N2 upon B21 N2 minus B21 into N2. Dividing both the numerator and denominator on the right hand side of the above equation with B21 into N2. So we have obtained rho V is equal to A21 upon B12 upon N1 upon N2 minus B21 upon B12. આપણે જાણીએ છીએ કે N2 upon N1 is equal to E raised to minus E2 minus E1 upon KT. આપણે વેલ્યુ જોઈએ છીએ N1 upon N2 ની, તેટલા માટે શું થશે તો કે N1 upon N2 is equal to HV upon KT. HV એટલે E2 minus E1. So we obtain A21 upon B12 bracketમાં 1 upon E raised to HV upon KT minus B12 upon B12. To maintain thermal equilibrium, the system must release energy in the form of electromagnetic radiation. It is required that the radiation be identical with black body radiation and be consistent with Planck's radiation law for any value of T. According to Planck's law, rho ની value હશે 8 pi hv cube into mu cube upon c cube into 1 upon E hv upon kt minus 1, where mu is the reflective index of the medium and c is equal to velocity of light in free space. Now we compare energy density equation 3 and Planck's equation 4. Energy density અને Planck's law ના equation ને સરખાવતા આપણે A21 upon B12 ની value 8 pi hv cube into mu cube upon c cube મળે છે અને B21 અને B12 ની value 1 મળે છે. તેથી B12 is equal to B21. The above equation are known as the Einstein relation. The coefficient B12, B21 and A21 are known as the Einstein Coefficient. It follows that coefficients are related through B12 is equal to B21 is equal to C cube upon 8 pi HV cube into mu cube into A21. The relation 7 shows that the coefficients are both absorption and stimulated emission are mathematically equal.